Didn't aren't in my class yet.
Hold on. You got like 50 subs.
No, 73. All right,
My
at least
bad.
what it was at the beginning of the week, that's what somebody said. All right, so we have a shared angle between this triangle and this triangle. Now, why am I focusing on these two triangles if I want these two? Here's why. If I can prove that this triangle is similar to that triangle, I can say that this relates to this, right? And notice that DE and AB are the bases of these two triangles, right? So it gets me the bases of these two. So that's why I'm going to go after these, so I can get some more information about this, because right now I have no information about those triangles. I'm also going to prove that DE and AB are parallel, and I'm going to use that to my advantage. Parallel is going to get me a lot of angles, and then I'll have enough to prove these similar, and then I can get this relationship, okay? So, right off the bat, by a shared angle, if you were absent, make sure you're really paying attention. Angle C congruent to angle C. Some of these are really tough. Not a single one of you in here, either present or absent, is smart enough to do this on your own right off the bat. I promise you that. This is really important stuff. If you get it, right, that's great. Make sure you really get it, because we're going to build on this through the rest of the semester. No joke. We did part of it, not all of it. So we've got angle C right here that's shared between the top triangle and the whole triangle. Now I've got enough information to say SAS basically, right? Remember when we talk about similarity, the triangles have the same angles, but they have proportional sides, right? So this triangle at the top has a segment of one red, right? And the triangle here, this big triangle, is two reds, right? So they're proportional, related to half. Same thing over here. This is related by half. So both sides are proportional to each other, right? Half versus half. And they share an angle between. So I can use side-angle-side similarity to prove that this triangle is similar to that. Now I've talked about the angle, I haven't talked about the side, so I need to do that. I'm going to say that CD in the top triangle is proportional to CA the same way that CE over here is proportional to CB, right? Everybody cool with that so far? Now, not only do I know that they're related, right, but I know how they are related. They're related by half. This is half of that, that's half of that. So I can write that. Their relationship is half. Now, if I had gone from big to small, I would have written 2 over 1, right? Which would have been relationship 2. CD is half of CA. If I flipped it, it would have been CA is double CD. You smell when I'm stepping in there with flipping the fractions? David? Not at all. All right. Shared angle, we good? This triangle and that triangle share the same angle?
Yeah.
Okay, cool. CD relates to CA, right? It's half, right? The same way that CE relates to CB, that's half as well. This could be 4 and that could be 8. This could be 3 and that could be 6, but at the end of the day, it's half, right? So the way they relate is by half, right? If that was 4 and that was 8, 4 over 8 reduces to a half, right? So that's how we know that. So we know that it's similar by any of these properties. If we have 2 matching angles, the triangles are similar. If we have 3 proportional sides, right, not the same, but relatable, right, and they all relate the same way, then the triangles will be similar. Or if we have 2 sides and an angle in between. Notice I have 2 proportional sides with an angle in between. So we're going to say by SAS similarity, the top triangle CDE is similar, not congruent, but similar to the big triangle. So when I match these up, C, this angle here in the top triangle, is the same angle with the bottom. So C goes to C. D is made up of the red side and the unknown side, right? So if I go to my big triangle, red proportional side and unknown side, that's angle A. E, blue side and unknown side, blue proportional side, unknown proportional side, right? So it's going to be a B. So I've proven that that triangle is similar to that triangle. That means all their angles will match and their sides will be similar. So you know how we use CCP for congruent? Well, for similar triangles, we're going to use CSP, corresponding similar parts. So now to prove that, I'm going to say by CSP. I know that this angle right here is congruent to this angle here. Because if you look, angle CDE, first, second, third, is congruent to CAB, this angle here. So I get that this angle and this angle are congruent by CSP. So I'm going to write that angle CDE congruent angle CAB. Now, for this one, I was fortunate that it was all in the right order, right? It was first, second, third. I can also prove that angle DEC is congruent to angle ABC, right? But I don't care about that. That's going to be this side, DEC congruent to ABC. These two angles will be the same as well, right? I was just very lucky that they happen to be all in the same order. That was a coincidence, okay? First, second, third, they all match, so I can say that. Now that I've got that, I can also say that this side right here, this side will be proportional to this. Not congruent, right? We're not saying they're the same, but that they will be proportional. So I'm going to say by CCP as well, or CSP as well, I know that CD relates to CA. The same way CE relates to CB. The same way DE, right? How do I know that? DE is first or second and third, right? Should relate to AB. CD and CA go together, right? Yeah, not congruent, because they're not congruent, they're similar, right? CD and CA go together. DE and AB go together. And CE and CB go together. And how do they all go together? Well, if this goes together by half, and they all go together by half. Otherwise, it wouldn't be similar. And we said they have to be, right? Everybody cool with that so far? Not at all? Evan, do I have you up to here?
Kind of.
Do I have you up to here? Red. Okay. This triangle shares the same angle with this one, right? I know that this on the small triangle relates to the big triangle side by half, right? And at this side also relates by half. So both of these relate by half. So now I've got two similar sides, right, that I've shown. CD and CA go together, CE and CB go together. So I got two pairs of sides, right? 1 and 2, 1 and 2. And they relate by half. So I've got side, angle, side similarity. So this triangle will be similar to this triangle. Cool. Danny.
Is it just, why didn't you shade in angle E and angle B?
I could have done angle E. Angle E is angle CED, and if you notice, CED is first, third, second.
Yep.
This is first, third, second. So I could have done that. I just don't need it.
Alright.
Okay. I could have also shaded in a bunch of vertical angles, right? Again, lots of things are helpful, but not everything will actually be useful. Does that make sense? I'm sorry. Let me say it again. Lots of things will be true, but not everything will be helpful. For instance, in the context of this problem, if I were to tell you the truth that turtles can breathe out of their butts, would that be useful for this? No, but it is true, right? Lots of things are true, but not everything is helpful. So I could get these together, right? CED, CED, first, third, second, and CBA, first, third, second, be congruent. But I don't need it, okay? And I'm going to show you how to discern what you need and what you don't need, right? But right now, just trust me. So we've got this. How did I get that? So Evan, after I said that they're similar, I can use CSP to match up their stuff. So see how CDE is first, second, third, right? First, second, third over here must be congruent. So angle CDE should be congruent to angle CAB, and it is, right? Then I also matched up their sides. CD should go with CA. Not congruent, but proportional, meaning they relate to each other, right? We show that by division. And DE and AB should go together. And CE and CB should go together. Now, I said earlier that CD and CA and CE and CB relate by half, right? That's half of this. So, if they're similar, which they are, then I should be able to say that they all relate by half. So that will be half of this. Now, here's how I'm going to mark that on my diagram. I'm going to put a point here. I'm going to say let M be the midpoint of AB. Okay? And then I'm going to say, therefore, based on this stuff, AM is congruent to D, and BM is congruent to D. Do you see how I made that, where that's half of this? Right? That's how I marked that on the diagram. Does that make sense? Right? Sometimes it's useful to put in a point so you can do something like that. So I'm going to say DE congruent to AM congruent to BM. everybody cool with that? I just did that so I could mark it in my diagram. Because how do I show that that's half of this without doing something like that? I don't know. So I made that 2 greens and that 1 green. Are we cool with that idea? Okay, cool. Evan, do we feel
Yeah,
better?
Joey, so you should move.
Red. Okay, so here's what I've got. I've got a set of sides that are similar for these 2 triangles, right? Now if I get some more angles, maybe I can get something done. So here's what I'm going to do. The reason I got this angle is because I know corresponding angles postulate. And it says that if I have 2 angles that are corresponding, congruent, then I must have parallel lines, right? That's the converse of cap. So again, let me bring you back to where we were yesterday. Corresponding angles postulate. I've got 2 parallel lines, right? If the lines are parallel, then the transversal cuts it, the angles are going to be what? They're going to be congruent, right? Corresponding angle stage. Those are going to be the same. So if I draw that out up here, you guys would know that. If I had 2 parallel lines cut by a transversal, I would know that by cap, those 2 angles are the same, right? Cool. Cap converse is the reverse of that. So normally we say, if the lines are parallel, then the angles are congruent, right? Converse flips that. If the angles are congruent, then the lines must be parallel. So let me write what that means. 2 random lines, don't know they're parallel. But if I know that these 2 angles are the same, those are corresponding angles, right? So by cap converse, if those angles are the same, what do we know about the lines? The lines must be what? No, line, nope. Hey, cap says if the lines are parallel, then the angles are congruent. Cap converse would say if the angles are parallel, or if the angles are the same, then the lines are what? Parallel. Are you bored or do you not get this?
Board.
Both.
Both. What I'm talking about right now.
Oh, I got that part. I thought you meant like the whole thing.
What do you mean about the rest? What about the rest of this?
I can't even like explain it. So.
Do you get?
You know what I mean, right?
So I have you here.
Yeah.
Awesome. So what I've done is I got these 2 angles congruent. First, second, third, right?
Mm-hmm.
So now I know those angles are congruent. Look, aren't those corresponding? Aren't these the same as that? If I were to extend these lines out, I've got a transversal, 2 angles that are congruent. Right side of its intersection, right side of its intersection. So I'm going to say by cap converse, this line is parallel to this line. If those 2 lines are parallel, right, we have 2 parallels, transversal, those angles will be congruent. I'm saying the reverse of that. If the angles are congruent, then the lines must be parallel. Are you smelling what I'm stepping on that thing right there? Okay, so I'm going to write that. By cap converse. Bless you.
Thank you.
DE is parallel to AB.
Shut up.
Cool? All right, I'm going to back up and go over it again, because this is where we got to last time, I think. Did we do a little bit further, Ellie?
It's like different, like completely. I think. Like I don't have the midpoint thing right now, but I have that cap converse thing right in.
That's okay. I did the midpoint just so I could mark the diagram. I think we did that. So, shared angle between the top triangle and the whole triangle. With me there?
Yes.
Okay.
Is that a-
This side is half of this side is half of that side, so they're proportional, right? They're both half. If this was half and that was a third, they wouldn't be, right? But they're half and half. So I wrote that. So I've got 2 proportional sides with an angle in between. That's this guy. They must be similar, okay? If they're similar, I can use CSP to match up their stuff. I matched up CDE with CAB because they're first, second, third, right? So that angle and that angle must be the same. I also know that their parts, like their sides, should be the same because look, CD and CA are both first and second here and here, right? DE and AB are second and third, and then first and third are CE and CB, so they go together. Now I said earlier, these guys are a half, right? So if those are equal, then that must be a half as well. Okay? So this should be half of that. That's what we just said. So in order to mark that on my diagram, I had to put a point here so I could show that that's half of this. Okay? That's all I did, right? And then I said, now that I've got those angles, they're corresponding angles. So if those angles are congruent, these lines are parallel. That's what this is. Normally what we do is we say lines are parallel so I can get those angles, yay, right, cap. But I say that cap has a converse that is true, meaning we can flip it around and say if the angles are the same, then the lines must be parallel. All right. So here's the deal.
Yep.
Check it out. This angle right here is congruent to this angle right here. Here's why. If I were, don't do this, if I were to extend these out, they're parallel, right? Do you see how BD is a transversal? It cuts the two parallels. I have something like this going on. Do you guys see that? Do you see that? There are two transversals, right? We have lots of them, right? All over the place. But focus on BD. I've got this going on. Do you see it? Okay. So if I were to extend this out, this angle right here would be the same as that angle there by cap. Here and here would be the same. And then by vertical, I get that. This angle would be the same as this angle, right? That's what I'm saying here and here. And then by vertical, I get this one, right? Are we cool with that? Awesome. All right. So cap here and here, vertical, get this. So I'm saying you can do that. You can do extend these lines out, do all that crap, right? And get that these are the cap, and then use vertical to get this, right? But there's a shortcut. Remember alternate interior angles theorem, right? The proof for alternate interior angles theorem, meaning we can prove it, is that look, cap and then vertical, right? See how the alternate interior angles are always congruent, right? Instead of proving it every single time and being like, look, this is cap and that's vertical, right? Save yourself some time. Save yourself some ink. Alternate interior angles are congruent. Boom. How do I know they're alternate interior? Here are the parallels. Are those in the interior of the parallels? Yes. Yes, they are. Here's the parallels. There's the interior, right? Are they alternate, meaning on opposite sides of the transversal? Here's the transversal. That one's on the top, that one's on the bottom. They're on opposite sides of the transversal, so they're alternate because they're on opposite sides. They're interior because they're on the inside of the parallels, so they should be congruent. So I'm going to say by alternate interior angles theorem. I haven't used that one before. We've learned about it, but we haven't used it. Angle, I'm going to call it EDF. Congruent to angle ABF. Cool. So those two angles are congruent. Now, could we do the same thing for the other side? Yes. Alternate interior here and here, right? So this angle would be the same as this bit of this angle, okay? I'm not going to do that. Instead, I'm going to go for the easy angle. I'm going to go with these. How do I know these two are congruent? Vertical, right? Could you have done the other ones? Sure. I'm going to write vertical. Okay? I think a lot of you guys would have seen that from the beginning. Can't call it angle F. The top one I'm going to call DFE. And the bottom one I'm going to call AFB. All right, so does everybody see how I got the dark blue angles? Alternate interior, okay, right, cap then vertical if you want, right? You see how these are the same? Vertical. Do I have two angles that match for both these triangles? Yeah, I do. So what do I know about them? If I've got two angles that match, what do I know about those triangles? They're similar by angle-angle similarity, right? So I'm going to write by angle-angle similarity. We're almost done. Triangle. What do you want to call the top one? This one right here.
CDE.
Well, we have D, E, and F to deal with.
DE.
Yeah, this top one.
You said the top one.
Yeah, I did. What do you want to call it? DEF? Def. Triangle def.
Yeah. Dave, shut up.
Hey. All right, so I wrote DEF. D is the blue angle in this triangle, so what is it going to match up with in the bottom? B, right? So D goes with B. E is next. E is the unknown angle. That's this guy here, right? I don't know what this particular angle is. I know this big guy, but I don't know what this one is. So E is going to go with A. And then F, well, F in this triangle is going to go with F in the bottom, right? So we have def and baff. You don't have to take bath.
Yes. Shower.
So those triangles are similar. All right, so what? Remember our goal. We want to prove that BF and DF are related. Well, if the triangles are similar, their sides are related, right? So here we go. BF and DF is what we want. Let's look down here. By CSP. BF and DF are first and third, right? So I'm going to write that. I'm going to start with the right side triangle because they wanted BF on top. Okay, so I'm going to start over here. BF must go with DF. The same way that we want AF and FE. Let's find it. AF is second and third. What's AF going to go with on the other triangle? EF, right? Now, how do we know that those equal 2? Well, we did BF and DF. We did AF and EF. What are we missing here? AF, BF. We're missing AB, right? BA. AB relates to DE. And if you notice, AB and DE are related by what? AB is double
Parallel.
DE, right? No, we're talking about their lengths.
Oh.
See how that's already double of DE? So AB is twice as big as DE, right? That's what we said here. That we already knew about. It was 1/2, but we flipped it, so it's 2/1 now. So now I can say this. All of those must be related 2/1. So what does that mean? That means that this right here is twice as big as this. And this right here is twice as big as that. That's what they were talking about. Because these two are twice as big, the rest must be twice as big, right? So last but not least, I'm going to write exactly what they wanted. What is 2/1 reduced to? 2. I'm going to back up and go over it again, don't worry. But let me tell you what this means. We took a generic triangle. Is this triangle isosceles? No, it's got 2 different sides, right? Could they end up being the same? Sure. But right now, all we know is that this and this and this could be different, right? One could be red, one could be blue, one could be green. Turns out that the red and blue could be the same someday, right? But we don't know, right? In general, they're all different. We took a random triangle and we connected its vertex to its midpoint, vertex to midpoint. Yeah, we did a little connection here to help us out, right? But what we're saying is this. Any triangle you draw, even this one, if you take a vertex and connect to the opposite midpoint, and a vertex and connect to its midpoint, where they intersect will break up into 1/3 versus 2/3. So this whole line right here, right? That's 1/3 of that line, that's 2/3. In other words, if this were 3, this would be 6. This is double of that, always. So if I gave you a problem, and I gave you this, and you know those are midpoints, right? And those are vertexes, right? These lines intersecting. If I told you that this bit was 4, this is the bigger bit, right? What would this be? If that's 6 and that's 3, this is 4, this would be 8. Try again. We're going from big to small. Small. We're going from big to small. 4, 2, 2. In fact, if I gave you any triangle like that, here's another weird one. And I gave you this.
Trying to get your snacks or
And I told you this was 7. Well, then this must be half of 7. 7 halves. If I told you this is a small piece. If I told you this was 6, how long would the bigger piece have to be? If the small piece is 6, what's the bigger piece have to be? 12. Always. No matter what triangle you have, no matter what you do, where they intersect will divide up those lines into half and double. That's what we proved. So, and the reason for that is, look, those guys will always relate by double, right? The small piece will relate to the big piece by double. The small piece will relate to the big piece by double. This guy will be double, or this guy will be double of that. This guy will be double of that. Okay, so back it up and go over it again. Here we go. I want to get these two triangles similar. Okay, this one right here and this one right here. So what did I do? I proved this one and this one similar so I could get those sides matching. Right? If that's 1 to 2, that's 1 to 2, this is 1 to 2. I said that those were similar. I got these angles because they were similar, right? By CSP. And then I said those are parallel. If those are parallel, then those are alternate interior angles. And I've got those for vertical. So now I've got angle, angle for these two pink triangles, and they're similar. If those two triangles are similar, their parts should be similar. So I wrote that here. And I noticed AB, DE, I already knew what that was. I just had it flipped. I already know how this relates to that. So if they all relate the same way as this guy, then all of them should be 2 over 1. Flip. And I'm going to do it again. I wanted to prove these two triangles similar. This one here and this one here. So I proved this one and this one similar so I could get the sides to match here and here. Right? Notice how this small triangle has the bottom of this pink triangle, and this big triangle has the bottom of this pink triangle, right? So I got those bottoms. I also got these two angles because this is similar to that. I said those must be parallel, like corresponding angles postulate converse, cap converse, right? Which means these must be alternate interior. By vertical angles, I've got 2 angles for those pink triangles, so now they're similar. If they're similar, their parts should all be the same. So if that's double of this, then this should be double of that, and that should be double of this. And that's what I wrote down here. If you feel 40 to 30% okay about this, that's really cool. Is that where you're at? Okay. What is it? Next Thursday for that reason.
15.
All right. Let's try one that's difficult, but not that hard. Not as hard as this last one. Let's look at 8. First of all, they tell us C and D are right angles. And that's all they give us. Guys, what are we proving here?
A squared plus B squared.
Which is Pythagorean theorem. We're going to prove it. Remember, it's a theorem, right? We knew that it worked before. We used Pythag to prove distance formula, right? First
Mine's the
semester.
same thing as polar.
Now we're proving the Pythagorean theorem. Why is it true? This is one way to do it. There's lots of ways. This is the way we do it with similar triangles. So what we do is we have a right triangle, and we dropped a perpendicular. Remember, we're always allowed to do let there be line, right? So they just put a line in there to help us out, so we have multiple triangles to talk about. So here's what we're going to do. Notice that BC, its length is A. See how we use the big letters for the points, right? Point B, point C, point A. We use the little letters for the side lengths. This is useful because I could have written this as BC squared plus AC squared equals BA squared, right? But that would have been a nightmare, way too many letters. And so I can instead write, instead of BC squared, I can write A squared. Instead of CA squared, I can write B squared. Instead of BA squared, I can write C squared, right? So what we're going to do is we're going to get these triangles similar, switch out their parts for the little letters that represent them, and then we're going to prove that A squared plus B squared equals C squared. All right, buckle up. This is one you're going to have to do on your quiz. Exact same thing.
Right there.
Here we go. All right, so before we begin, how many triangles do I have in this diagram?
2.
1, 2,
3.
3. We've got a small, medium, and large. Baby bear, mama bear, and a mama bear. So the small triangle, pretend it has a 3, 4, 5, right? Maybe the medium triangle is 6, 8, and 10. Now, why do we call the large triangle?
Bigger.
Because it's the biggest, right? So it's got to be bigger than the medium. So I don't know, maybe it's like 9, let's do 12, let's do 12. 12, 16, and 20. All right, so check it out. The small triangle is half the medium, right? The medium is half the large. Is the small half the large?
No.
No, it's not. So check it out. Small and medium will be similar. Medium and large will be similar. Small and large will be similar in their own way, times 4, right? But it won't be similar in the same way that small and medium are. So the way small and medium relate is by double, right? The way small and large relate is by quadruple. So small and medium are going to work together. Medium, large are going to work together. Small and large are going to work together, right? But small, medium, large are never all going to work together at the same time. You smell what I'm stepping in there. They all relate by a different thing. Before we said on our last one that everything related by half, right? Here, sometimes it's half, sometimes it's not. So we can't take all three at once, but we can take pairs, right? These two relate, these two relate, these two relate. So here's what we're going to do. We're going to prove that the small triangle relates to the medium triangle, and the medium triangle relates to the big triangle, and we're going to prove that the small triangle relates to the big triangle. And then we're going to write down all the parts. We're going to switch out the parts for little letters, and we're going to get this. It sounds super complex. It's a lot of writing, but it's not complex. First hour, love this. Okay, here we go. Let's get the small triangle and the big triangle together. So ignore the medium. Everybody see the big triangle? Everybody see the small one? Okay, check it out. What angle do the small triangle and the big triangle share? What angle do the small triangle?
D and C.
What angle do the small triangle and the big triangle share? Share, not congruent. Yes, that has a right angle and that has a right angle. I'm talking, what do they share? This one and this one. What do they share? What angle? What angle do they share? Meaning overlap.
C.
C is a right angle, so they both have right angles. You're right. This one has a right angle at D. This one has a right angle at C. But they don't share it, right?
Which ones are you talking?
The small triangle and the big triangle. B. Let me show you. It's okay. You'll see it. You'll see it. See how the small triangle has angle B? See how the big triangle also uses angle B? They share that angle. So we can say by shared angle, angle B congruent to angle B. And now check it out. Small triangle has a right angle and a purple angle. Does the big triangle, the biggest triangle, have a right angle and a purple angle? Small triangle has a right angle and a purple angle. Does the big triangle also have a right angle and a purple angle? Right angle, purple angle. Right angle, purple angle. So by AA similarity, small and big are similar. I'm going to write S for small inside the triangle. Okay? The small triangle. We got to call it by its big letters. I'm going to call it BCD. Is similar to the large triangle. What are the letters for the large triangle that match up? Well, check it out. Small triangle, B is the purple angle, right? What's the purple angle in the big triangle?
B.
Also B. So B goes with B. C is the unknown angle in the small triangle, right? It's not the right angle, it's not the purple angle, it's the other one, right? What's the other angle in the big triangle? A. So C and A go together. D is the right angle in the small triangle. So where's our right angle in our big triangle? C. How do we feel about that? Okay. So the triangles are similar because they have two matching angles, right? They shared an angle, so it was easy to find it once you saw it, right? Again, seeing it's the hard part. Cool. Now let's get our other triangles together. We have small and large together. Let's get medium and large together. So the medium triangle and the large triangle. What angle does the medium share with the large? They share A. Do you see it now? Medium triangle has A. Large triangle has A. By shared angle. Angle A congruent to angle A. What can we say about the medium and the large triangle now? Medium triangle and the large triangle. Are they similar? How do you know? Don't they have two angles that are the same? Green and right. Green and right. So by AA, they're similar.
Okay, similarity.
Medium triangle, similar to large triangle. Okay, medium, let's call it by its big letters. We've got A, C, and D, so I'll call it in alphabetical order when I can. The big triangle. Notice that A is the green angle on the medium triangle. What's the green angle on the big triangle?
A.
Also A, they share it, right?
Similar.
Sharing is caring. What's C on the small triangle? It's the unknown angle, right? It's not the right angle, it's not the green angle, it's the other one. C, angle C matches up with angle what on the big triangle? The unknown angle. Well, if it's not the green and it's not the right on this guy, it's not the green, it's not the right, and it must be B. So we just proved that B and C on this guy
We did.
and B on that guy are both purple. They've got to be, right? That's green, that's right, so what's left over, right? That's green, that's right, so what's left over must be purple. We'll do that in a second. D
Wait.
on the medium triangle. That's the right angle, correct? What's the right angle on the big triangle? What's the right angle on the big triangle?
C.
C.
A, B, C.
All right. Before we go any further, let's match up those purple angles. By CSP, we proved that C on the medium triangle, this angle right here, this much of it, must be the same as B in the other one, right? See how C and D go together? Now we can't call them C and D because there's multiple angles here, right? I can call this one B. What am I going to call angle C down here? If I call it BCA, I'm talking about the right angle. I want to talk about the purple. DCA. I'm going to do alphabetical order, ACD, but you see what I'm talking about here? The two purple parts are the same. And they have to be because we know the triangles are similar, so their angles should all be the same. We have a right angle and a green angle. We've got a right angle and a green angle, so the purples must go together. All right, now we have two more triangles to work with. We've got small and large. We've got medium and large. We need to get small and medium together, right? So now we're looking at these two. Here we go. Do we have enough information to prove small and medium the same? We do. We have a purple and a right angle. We've got a purple and a right angle. So by angle, angle, they're the same. Small triangle, similar to medium triangle. Small triangle, I'm going to call it BCD, alphabetical order. Shut up, Danny.
Sorry.
B on the small triangle is the purple angle, right? What's the purple angle on the medium triangle? C. So write C. Next letter is C on the small triangle. That's this unknown angle, right? It's not the right angle. It's not the purple angle. So what is it going to go with on this one? This one's not this one right here, angle C, is not the right angle. It's not the purple angle. So what angle is it going to go with on this? It must be A. So we just kind of proved that those are both green, aren't they? That's interesting. This one, D is the right angle. What's the right angle on the medium triangle?
C. No. D.
Also D, right? So we could use CSP to prove that these two are green. I don't care about that though. Okay, I'm done. I got all my triangles together. I got small and medium, medium and large, small and large. I got all my combinations, okay? So here's what we're going to do now. I'm going to use CSP to match up their sides because I want to know about their sides, right? Here we go. By CSP. Don't copy this down. Watch me. BC is going to go with what? The same way that CD goes with AC. The same way that BD goes with BC. Good. Next one. AC should go with AB. The same way that CD goes with. The same way that AD goes with AC. Good. Next one. BC should go with the same way that CD goes with. The same way that BD goes with. Okay, cool. I just got that all by CSP. We cool with that?
Right.
Why am I doing that? Because I want to know about sides, right? Now, they're talking about sides in terms of little letters. I've got big letters. Let's switch them out. You guys see how BC is the same as A? I'm going to rewrite this. Okay? Instead of BC, I'm going to write A. What's BA in the diagram? C. CD is this. Oh, we need a letter for that. Let's call it G. Okay? AC is B. Right? You guys see how AC is B? BD is F. And then I've got BC. BC is A. Okay, pause. The rest I'll do really quickly. Okay? Do you see how I got those letters? I switched them out. What do you notice? I've got two A's here, don't I? Cut out the middle guy. What if I wanted to move that A over? What would I do? Divide by A, how do I move it over?
Multiply.
I multiply. And if I multiply by A, multiplication goes on top, right? What's A times A?
A squared.
A squared. So I've got A squared over C. How do I get rid of the divides by C?
You multiply.
I move it over multiplication. So I know that A squared, therefore A squared equals C times F. Do you see that? A squared, C times F.
Get rid of it.
I'm going to do the same thing for the next one.
Oh, darn it.
Darn! Try it on your own. See if you can finish it.
No.
Believe in you.
Oh.
See you on Monday.
I'm gonna have
No.
Yeah.
I won't be here.
Yeah, I'm planning on being sick.
First hour got through it, so if you want to watch the cheat, you can watch them.
That's right. I'm feeling like I'm gonna be sick on Monday.
I'm planning
Yeah,
on,
I
I'm
understand.
planning on being sick.
Class has been really weird. We've been stopping in the middle a lot because I've had to go back and teach people that next.
I need you to sign that green schedule paper.
All these different words, dude. There's too many of them. Like cap.
Yep. Which is why when things are easy, you shouldn't zone out.
Similarity.
Because then there will be too many of them to learn all at once. Hi. Today we're going to prove the Pythagorean theorem.